RC in series circuit. Consider an AC source of RMS voltage is connected in series to a resistor and a capacitor. The RMS current passes through the resistor and the capacitor is equal because of the series connection between both components. The RMS voltage across the resistor and the capacitor are given by the Vrms across the capacitor equal to Irms Xc, and the Vrms across the resistor is equal to Irms-R. From the phasor diagram, the Vrms across the resistor is in phase with the Irms, and the V across the capacitor is lags behind by pi over 2 radian. From this phasor diagram, we can calculate the RMS supply or Vrms or total voltage of the circuit. So the total voltage of Vrms can be calculated equal to Vrms across the resistor plus Vrms across the capacitor. And then we substitute again where the Vrms across the resistor is equal to Irms R, and Vrms across the capacitor is equal to Irms Xc. And then when we rearrange the equation, the current, because the current flow through the resistor and through the capacitor is the same current, so we can get a Vrms is equal to Irms times R square plus Xc square, where Vrms divided by Irms is equal to the impedance. So we can calculate the impedance of the RC in series by using this formula. Impedance is equal to the surd R square plus Xc square. And we can calculate the angle between the Vrms across the resistor to the supply voltage is tangent theta equal to Xc divided by R. And the phasor diagram can be illustrated. The phasor diagram in terms of R, Xc and Z can be illustrated like this. RL series circuit. Consider an AC circuit of RMS voltage is connected in series to a resistor and an inductor. The RMS voltage across the resistor and the inductor is given by the Vrms across the resistor equal to Irms-R, and the V across the inductor is equal to Irms-XL. And as we know, the resistor and the inductor is connected in series in this circuit. So the current flow through the resistor and the current flow through the inductor is the same current. From the phasor diagram, Vrms across the inductor is leads Irms, and we're gonna calculate the Vrms, which is the supply voltage across the or in between the RMS voltage across the inductor and IRMS. Based on the phasor diagram, the RMS supply voltage or the total voltage of the circuit can be calculated. VRMS is equal to the surge VRMS R square plus VRMS across the inductor XL square. And then as we know, the VRMS is equal to the IRMS. So we substitute into the formula and then we get the root mean square voltage is equal to the IRMS times surge R square plus XL square. VRMS divided by the IRMS, so we get the impedance of RL series circuit. So the impedance is given by Z is equal to the surge R square plus XL square. From the phasor diagram, the supply voltage VRMS leads the current IRMS by phi radian. We can calculate the phase angle of 5 or tangent 5 is equal to VRMS square divided by VRMS across the inductor divided by VRMS across the resistor. And then substitute VRMS equal to IRMSR or IRMS because across the inductor, so IRMS XL divided by IRMS R. And the tangent 5 is equal to the XL over R. So we can sketch a phasor diagram in terms of R, XL, and Z. RCL series circuit. In the RCL series circuit, the RMS voltage or VRMS is connected in series to the resistor, capacitor, and inductor in series. Means that the current flow through the resistor, capacitor, and inductor is the same current. And the voltage across the resistor, VRMS is IRMS R, and VRMS across the capacitor is equal to IRMS X C, and VRMS across the inductor is equal to IRMS XL. VRMS inductor in the RCL series circuits leads the IRMS, while the VRMS across the capacitor is lags behind the IRMS. VRMS across the inductor and VRMS across the capacitor is directed Y component. And the IRMS and the VRMS is always directed to the X component. We put the VRMS across the inductor at positive Y, and V across the capacitor is at the negative Y. Alright, from the phasor diagram, the RMS supply voltage of VRMS or total voltage of the circuit can be calculated using this equation. Okay, we just substitute VRMS across the resistor square plus VRMS across the inductor minus VRMS across the capacitor. Why? Because due to the phasor diagram, you see that the VRMS across the inductor is in opposite direction to the VRMS across the capacitor. So the equation become VRMS is equal to IRMS times surd R square plus XL minus XC square. This is because the VRMS across the inductor is longer than the VRMS across the capacitor. Depends on the questions. If the VRMS across the capacitor is longer than VRMS across the inductor, means that the VRMS for this phasor diagram is equal to R square plus surd XC minus XL square. For this example, we have the VRMS across the resistor is greater or longer than the VRMS across the capacitor. So, the impedance here, the impedance for this phasor diagram is Z equal to the R square plus surd XL minus XC square. And the impedance here for the XL longer than XC. The supply voltage VRMS leads the current IRMS by phi radian. So we can calculate the tangent 5 is equal to VRMS minus VRMS across the inductor divided by VRMS across the resistor. And tangent 5 is equal to XL minus XC divided by R. So the phasor diagram in terms of R, XC, XL, and Z can be illustrated like this figure.